Okay, so today we're going to be talking about acid rain and all of its impacts and the ways that it is caused and the impact that it has on the environment and on human beings. So let's jump right in to our PowerPoint for today. And we'll take a look at acid rain. Okay, so we're going to more broadly talk about acid deposition because acid deposition covers acid rain as well as fog, sleet, snow, but also drier forms of acid deposition. So, wet deposition is what we normally think of. That would be acid rain, even acid snow, particularly in the US Northeast, as well as acidic fog. But there's also dry deposition, and that would be aerosol particles and even gases when it's the opposite of sublimation. So they deposit out. So they go straight from the gas form into the solid form, and they usually do that on a surface. So, what causes acid deposition? Well, we're going to talk about two main sources of acid deposition. We're going to talk about nitrogen oxides and we're going to talk about sulfur oxides. And so, nitrogen oxides are things with the formula of NO. So, whether it's NO, N2O, or NO2. And remember, we abbreviate these as NOx. And then we also have the sulfur oxides, which could be most commonly sulfur dioxide, but it can also be sulfur monoxide. So naturally, lightning and microbes both contribute nitrogen oxides to the atmosphere. And sulfur oxides, pretty much in the natural scheme of things, are only contributed by volcanoes. On the other hand, anthropogenic sources, so those human sources for nitrogen oxides, are motor vehicles and coal burning power plants. The more significant contributor to the nitrogen oxides is motor vehicles or anything that is powered by petroleum. Petroleum has a higher nitrogen content than coal does. And so when it's burned, it results in more nitrogen oxides than coal does. Now, that said, coal burning power plants are a significant contributor of nitrogen oxides, but petroleum combustion is more significant. When it comes to sulfur oxides, coal burning power plants are the number one contributor to sulfur oxides in our atmosphere. And so we need to make sure that we understand that sulfur oxides come from power plants, particularly coal burning power plants. Nitrogen oxides come both from motor vehicles and from those coal burning power plants. We've talked about this before. Atmospheric pollution does not stay where it is created. It travels with the wind, it travels with those global air currents. And so when we have these acidic gases released into the atmosphere, they get carried by the wind, they get dissolved with the water in the atmosphere, and that dissolution creates a reaction. So we now, instead of having nitrous oxides and sulfur oxides, we now have sulfuric and nitric acids dissolved in our rainwater, and that's the acid rain. Remember that all rain is slightly acidic because of the carbon dioxide in our atmosphere, usually around a pH of 5.6 to 6.0, so well below neutral. Remember, acidic pHs are below 7. Adding acid to something is going to decrease its pH. Let me say that again. Adding acid decreases pH. So when we have nitric acid and sulfuric acid, that takes that pH down even more. And so when we have that acid rain falling on our landscape, that acid rain can directly kill plant life. It pollutes rivers and streams. It can erode stonework. We're going to talk about all of those in detail in just a second. But the risk is always to the downwind communities. So the pollution does not stay where it is created, it flows with the wind. So the communities that are downwind of the pollution creation are going to be the most at risk. So let's talk about those impacts. Number one is the acidification of soil and bodies of water. And you remember when we talked about the pill bugs and we did the range of tolerance for the pill bugs, that all organisms have a range of tolerance. They have a range of conditions in which they can live. And we talked about light, and we talked about temperature, and we talked about moisture, but we also talked about pH. And so most aquatic organisms have a range of pH in which they can thrive, and they have a range of pH in which they can survive. And if we go below that thrive and survive range, then we're going to directly kill aquatic organisms. Another significant impact is when we acidify soils, that can leach out metals from the soil. And that has a couple of different impacts. One is that some of those metals are necessary for plant growth. And the other is that those metals that were being stored in the soil are now leaching into the water, whether it's groundwater or surface water. We now have dissolved metal ions in the water. And those, again, can be toxic to aquatic life, particularly the invertebrate aquatic life, which is relatively low on the trophic chain, which means that it's going to impact the entire trophic pyramid. Acid rain also dissolves some stone, particularly limestone, which is what we use a lot of the time, as you can see in the picture, in statuary. Limestone is the biggest component of marble. And so even marble statues are dissolved by acid rain. And it's not just statues, it's buildings as well. So significant impact on human-made structures, particularly if they're made of limestone or of marble. So those are the impacts. What can be done to mitigate that impact? Well, there's some natural mitigation of this impact. Limestone, as I've said, reacts with acid. And so anything that contains calcium carbonate, that can neutralize our acid rain. It basically is a buffer. So areas that have large amounts of limestone in their bedrock are more resistant to acid rain because the limestone in the bedrock actually neutralizes the acid rain. In addition, as you can see in the image, some places, in order to deal with acidification of lakes or streams, are actually dumping powdered calcium carbonate, powdered limestone, into the streams or on the banks of rivers in order to neutralize some of that acid. And that's what you're seeing in this image here with the helicopter. It's actually dropping powdered limestone into that body of water. West Virginia did a lot of that, both from acid rain impacts from all of the coal-fired power plants, but also they've done it in order to neutralize coal ash spills. But that's a story for another day because today we're talking about acid rain. Okay, so let's talk about how this works, what happens here. So we have the emission of sulfur dioxide and nitrogen oxides that's carried by the wind. If it interacts with water, we get a transformation to sulfuric acid and nitric acid. That can either come out as wet acid deposition, so that would be rain or snow or fog. It can come out as dry acid deposition. So the dry acid deposition is sulfur dioxide or nitrogen oxide reacting with other things in the air to form sulfate and nitrate salts, particularly when they've reacted with something basic in the air like ammonia. This is the one good aspect of acid deposition. Those sulfate and nitrate salts are actually good for plants. You can remember, I hope, that plants need both sulfur and nitrogen in order to survive. And normally that's added in the form of compost or manure or fertilizer. So the deposition of sulfate and nitrate salts into soil is actually good for the soil, good for plants. So that is the one positive aspect of the acid rain cycle. You can see in this particular image that we have that lakes that are in soil that's high in limestone tend to be buffered. Shallow soil that does not have a lot of limestone, those lakes are much more likely to become acidic. So the location of the lake matters, because if it's deep in limestone, then it's going to be more neutralized. And then you have one more image, same thing. It comes out, it is distributed by wind. So remember, being downwind of the pollution source is really important in terms of the amount of acid rain or acid deposition. And so it falls as rain, it acidifies soil and surface water. It can actually acidify groundwater sources as well. That's it for acid rain. As always, if you have questions, let me know.